Nesting multiple parts in a single workpiece is a proven way to increase productivity. It reduces manual handling, lowers the risk of misloads, and keeps the spindle cutting longer, all while sharing tool changes and rotary moves across multiple parts. Well, now this approach goes further. New enhancements introduce pattern definition and better strategies to optimize the entire workflow from setup to G-code. Program once at the root part level and let the system manage the rest, resulting in shorter cycle times, simpler workflows, and higher overall efficiency. In this video, we'll demonstrate the capability on a real production milling scenario. Part copies make it easy to duplicate and arrange components across your workpiece. Choose from multiple pattern styles, circular, linear, grid, or free, for complete flexibility in positioning and nesting. Once the target part is defined within the workpiece, creating part copies is simple and direct. Use the part setup ribbon to add multiple instances of the same part within a single piece of material, making it easy to organize and prepare your workpiece for machining. You can define patterns quickly, adjust positions with intuitive controls, and see immediate visual feedback while staying in the setup context. This ESPRIT EDGE file already includes 2 workpieces mounted in parallel on the fixture. Each workpiece contains 8 individual parts, 1 master root part, and 7 associative copies. We'll start by creating a single facing operation to establish the top face of the finished workpiece. Because ESPRIT EDGE understands the root part definition, the associated part copies, and the overall setup, we can focus solely on programming the root. ESPRIT EDGE takes care of the rest. To preserve time throughout this highlight video, saved processes will be utilized. We will, however, review each pertinent setting in depth prior to operation creation. Notice that because this workpiece includes part copies, a part copies category appears in the operation settings. Since we want a single facing operation that machines the full length of the workpiece, we'll enable Apply Once. Let's generate the toolpath. After creation, notice that a single facing operation appears in the Operations tab, spanning the full length of the bar. When switching to the Machine view and opening the Program tab, you'll see that a single machine operation is created for each workpiece. This ensures clean, organized programs without unnecessary duplication. Next, we'll move on to drilling the part's large center hole. For demonstration purposes, we'll disable Apply Once. Let's generate the toolpath. After creation, notice that a single drilling operation appears in the Operations tab. While it may look like only one hole is being drilled, the in-process stock update shows that every part occurrence is drilled. When switching to the Machine view and opening the Program tab, notice that multiple machining operations have been created, one for each part occurrence. This is a direct result of disabling Apply Once, which instructs ESPRIT EDGE to treat each part copy as an independent machining instance rather than consolidating the operation at the workpiece level. Taking it one step further, if we generate NC code, notice that each part occurrence produces its own CAN cycle output, G81, G80, repeated for every operation. While there's nothing functionally wrong with this output, the sheer number of operations generated when the tombstone is fully loaded, along with repeated CAN cycles, may warrant a more streamlined NC code format. Ideally, a single CAN cycle per workpiece would improve overall readability and maintainability of the NC program. To achieve that, we'll edit the existing drill operation and enable Apply Once. Immediately after enabling Apply Once, notice the updated preview in the graphics area. Let's regenerate the toolpath. After regenerating, notice that a single drilling operation still appears in the Operations tab. This time, the toolpath preview clearly shows the operation applied across the full length of the workpiece, drilling each part occurrence as part of one consolidated execution. When switching to the Machine view and opening the Program tab, you can see that a single machining operation is now created per workpiece. Rather than duplicating operations for each part occurrence, ESPRIT EDGE consolidates execution at the workpiece level. If we regenerate the NC code now, notice that each workpiece is driven by a single consolidated CAN cycle. Rather than repeating G81, G80 blocks for every part occurrence, the drill positions are grouped within one cycle per workpiece, resulting in a cleaner, more readable NC program. Next, we'll focus on removing the bulk of the remaining material, finishing the part periphery, and completing the remaining OP10 operations. Note that Apply Once is enabled. Let's generate the toolpath. After creation, notice that a single rough periphery operation appears in the Operations tab. By processing the bulk material as a single workpiece level operation, ESPRIT EDGE minimizes unnecessary entries and exits that would otherwise occur when machining each part individually. If we switch to the machine view and open the Program tab, notice that the rough periphery operation is represented once per workpiece. This approach is possible because the fixture was produced on the same class of machine, ensuring precise and repeatable spacing between each part occurrence. That consistency allows ESPRIT EDGE to confidently apply workpiece level machining strategies without introducing positional risk. Notice the material left between each part occurrence. The end mill used for rough periphery was selected to maximize material removal rate across the workpiece, but its diameter prevents it from accessing these tighter regions. We'll address that remaining material next using a smaller end mill. As with previous operation, Apply Once is enabled. Let's generate the toolpath. After creation, the semi-roughing operation follows a similar pattern to the previous rough periphery pass. With stock automation, material is removed only where stock remains, eliminating air cuts and unnecessary motion in cleared areas. As shown throughout this example, part copies in ESPRIT EDGE decouple machining intent from part count and spacing through a true digital twin approach. When layouts change, whether it's the number of parts, their spacing, or the fixture definition, simply update the setup and the system automatically applies those changes across all machining operations. There's no need to build arrays, duplicate models, or recreate features for each occurrence. Program once at the root part, and the system handles everything else, from toolpath application and stock-aware execution to NC output, creating a programming process that is intuitive, resilient, and scalable. This is another example of ESPRIT EDGE's Program One Machine Many mindset in action, keeping setup, machining, and execution perfectly aligned as production scales. Thank you for watching this ESPRIT EDGE product video. For more information on this and other ESPRIT EDGE features, please refer to the release bulletin and product help.